Hello, this is Jim Sutton of Stone Tablet Innovations. We're going to do video blog number 9, which concerns IP connection with transport layer security, usually called TLS. This is very critical to any IoT application. So we're going to show you how to use the mbedTLS library tools, and we're to establish a secure and encryption connection with TLS. The prerequisite is installation of a common library file with headers and C functions, including Wi-Fi, and this is demonstrated in Video Blog 8, and when we actually run the build, you'll see that. A second prerequisite, of course, even to do this other thing, is to put in the Espressif IDF, which is in blog number 4. We're following the steps in the Espressif tutorial, but just showing more demonstrations. The target hardware is the same as the other video blogs. That's the DevKit C. So transport layer security, or TLS, is a widely adopted security protocol designed to facilitate privacy and data security for communication over the internet. And as I've mentioned before, Stone Tablet wants the best possible security, because our whole idea here is to allow you to control the devices in your house rather than someone else control the devices. So the primary uses are encrypting the communication between web applications and servers. This is what happens when you're browsing the web or loading a website on your browser. And actually, more important for us is encrypting what is called maybe the other communication, such as email. And in here, there's messaging, and including this Jabber XMPP protocol, which we'll get into quite a bit more, which is a great way of securely sending messages, especially when not all the computers are online at the same time. And finally, voice over IP, like Google Talk, is all using this. And to do this transport layer security, you need some libraries, and there are a whole bunch of potentials to do that. And you can look into them a little bit more on, I put a link here for Wikipedia, comparison of cryptography libraries. And in their comparison table, they had 15 major libraries. There are 4 that I think are particularly important for the ESP32, and I've listed them here. OpenSSL is very important because it's so commonly used. So if you find an application you're trying to port onto the ESP32, it most likely uses OpenSSL functions. And so you go, okay, let's put in OpenSSL and provide that on the ESP. But the code base of OpenSSL is very heavy. It's a lot of lines of code. And we don't have that big a processor here. So we'll get into that. The ESP32 and Espressif have made a wrapper to allow OpenSSL calls, but we'll get into that a little bit later. A boring SSL is a variant of OpenSSL by Google that's standard in Chrome and Android. It's very efficient, both from a code size and execution, and they have wrappers built into boring SSL in order to be used with, you can just take out OpenSSL and put in boring SSL. I've seen some examples of where people have used boring SSL with ARM processors, but we haven't seen in the Tensilica Extensa line of people using boring SSL as the main protocol. This mbed-TLS is a C language based set of libraries targeted at IoT, embedded in RTOS. It's what Espressif thinks is probably the best overall solution, and it's the default library set, and that's what we're demonstrating in this blog today. And it's again the default for ESP32. Wolf SSL is very interesting. It's also a C language, and actually it wants to do exactly what mbedTLS wants to do, and there's an option to use Wolf SSL libraries, but you're going to have to load them yourself, and we'll maybe talk a little bit more about Wolf in a little while. This is repeating a little bit. The mbed is the is the default library. Wolf SL can be used, and the Espressif API has information comparing Wolf SSL with mbed. The biggest advantage for Wolf is it supports TLS 1.3, whereas only 1.2 is supported. So it's a little bit later. The latest and greatest is supported by Wolf. The mbed component library is shown in components mbedTLS, and I think you'll see that in the demo, and you can download the Wolf SSL from this stuff in GitHub. The only reason we're using mbed here, mbed is what I kind of call it, is it's the standard that Espressif has used for their default. Its licensing is a little bit simpler than Wolf SSL, who will allow you to use their code for free, but they want to talk about it. And so this is a good company. They produce good code, and for some people it might be the best way to go. And as I mentioned previously, the Espressif IDF handles open SSL functions by supplying a component wrapper library, and you can find that under components, open SSL. And in this library, it doesn't contain any OpenSSL code, just the wrapper to mbedTLS to do the actual work. So theoretically, any code that has OpenSSL functions, you should be able to run with this wrapper and the underlying mbedTLS code to do it. You could always replace the OpenSSL calls directly with mbedTLS, but that has the problem of if the person whose code you're porting changes their code, you're now stuck with a fair amount of work to upgrade. So we're now going to start building the project in the same way we've built like the last 4 projects. So I'm going to go through these quickly. If I suggest that if you want more detail on running each one of these steps, look at the earlier Hello World or Blink examples. So we're going to make a project to enable TLS communication. So the first step is going to be to get a project framework. We're going to start with the example configuration in the Espressif examples folder. So under protocols, there's an HTTPS _ mbedTLS. I'm going to copy that. And we're going to go paste that into STI projects. And keep it in order, and that'll be 05 underscore. Now when we look in this, it has a CMAKE list file, which is obviously important, and it's looking for some extra components. We could leave it in here just like that, but I wanted all the components that the STI project needed to be in this folder, except for the core libraries. So I want to change this path. Instead of being examples, now it's located in STI projects, and it's 99 underscore common elements. So I'm going to save that and go back here and just show there's that 99 common components under STI projects, and ESP is the core path. So we've now established our framework, so we can go ahead with the building process. And now I have to do CD. All right, so we're in the project directory now, so I can do idf.python and set target, and it'll be ESP32. Again, that's telling the compiler what to make code for. And there's a lot more detail on this I think on tutorial 5. Okay, we're done with that, and now we want to do the menu configuration. So all right, and we can go into example connection configuration, and this is where we're going to connect using the built-in Wi-Fi on the ESP32. So this is where we can enter what the SSID of the Wi-Fi is. So let me just pause this for a second while I type the personal information in. Okay, I've got my SSID typed in, and now I'm going to put in my password, and I'll pause it again. So I got my password in there now, and just have to save it. And so it's saved, and we can exit. So now we can build it. I'm just getting the caps lock off. idf.python space dash port is com3 dash baud is 115200, and we got to flash it and monitor it. So we'll let it get started here, and then I'm going to pause it again so you don't have to wait while it builds the 945 objects it needs. So we'll come back when it's about 900. All right, we're at 941, and we'll finish the linking of the projects. Okay, it wants to connect, so now I have to press the boot key on the ESP32, and that gets it into bootloader mode, and we can see it's writing that now. So lucky you, I'm going to pause again while it finishes loading. All right, it's wrapping up at 100%, and it booted, and it's communicating with the website. Before we build this project, let's take a look at the underlying C file for a second. So file, open file, and this is the mbedTLS example main.c. Well, I might as well go in the right directory, just to STI projects, mbedTLS, main. Okay, so now we've opened this example, and this is a get example because we're going to pull back some information, and we're going to use the mbedTLS sockets, and we're going to actually get this from howsmyssl.com because it looks for security vulnerabilities, and we're going to use TLS version 1.2. 1.3 is out, but right now mbed doesn't support that. And let's see if anything else is interesting. So we're going to look at some of the libraries. This free RTOS is everything, in everything we look at. And I'm not sure where these LWIP are actually stored. They may be in the same directory with this mbed TLS. And so there's that web server, and we're going to contact it on port 443. And so at the bottom of this is probably the main where we'll connect to it, and then it's going to ask a couple of questions. Void app main, this will be what is started, and xtask create is what it will do, and so it's going to connect via Wi-Fi, and then it's going to run some negotiation with the website in order to establish SSL communication, actually TLS communication. And we're going to look at the, after we build the project, we're going to look at how it actually moves back and forth. The main thing I wanted to show in this part was how the libraries were set up. Well, I've took a screenshot of the monitor piece just to show some of the communications that's going on. Again, every 10 seconds it goes out to this How's My SSL website and performs a TLS handshake and gets some information. So where it says starting again up at the top, that's where it's probably done this a few times. So then it says connecting to my How's My SSL, and then it does performing the SSL handshake. It verifies the X.509 certificates, and then it negotiates the cipher suite. And over on the left-hand side of this page, what it describes is what that ECDHE really means. So the cipher suite is a combination of the protocol, key exchange, authentication, encryption, and hash. And so on the left here, I took those ECDHE and say, what does that stand for? It stands for elliptic curve, Diffie-Hellman, ephemeral, whatever that is. And then once the ciphers, once we're all negotiated, have agreement on the cipher suite, we get to the main HTTP requests. And I think there are 4 requests in there for information. And it writes 106 bytes to the website, and then it reads the response. So in here you can see that it's supporting a large number of different, we chose one of the cipher suites. This website is supporting quite a few, and one of the key is near this, all this white stuff, which is hard to read after this, is it gives some details on the connection, and it says TLS version : TLS 1.2, and it also sends back the website's rating, which is probably okay, which is the best rating this website will give. There's nothing above that. It's saying you've got very good tools in place, and all the correct protocols are in place. Obviously, you can study the security a little bit more. Really, in this demonstration, we just wanted to get the boilerplate in of how to do the secure TLS 1.2 communication with the mbed library. So in summary, that's what we were after: build, flash, and monitor a simple program to get communications going to the howsmySSL server.com. I want to thank you. Go ahead and subscribe if you like, and we're going to keep putting these up, working towards building some actual devices. So thanks again.